Hello guys, welcome back to my channel Learn with PR. In today's video, we are going to learn one of the most powerful sorting algorithm in data structure, that is heap sort. In previous video, we understood bubble sort, selection, insertion and merge sort. So today's we will understand what is heap sort, how it works, step-by-step example, why it is faster. So stay till the end. And if you are new to my channel, please do subscribe and press the bell icon so you never miss any videos. Now let's begin. So what is heap sort? Basically, heap sort actually is a sorting algorithm that uses a binary heap data structure. It works in two main steps. First, build a max heap. Second, remove the largest element one by one. It also gives time complexity as big O n log n, which makes it much faster than bubble selection insertion sort. Okay, so here I have written a small example, a small definition of it. That is a comparison-based sorting algorithm that uses the binary heap data structure. Right, a heap actually is a complete binary tree that satisfies the heap properties. Basically, they are two types: max heap and min heap. So max heap, you will say parent node is greater than the child here. But in min heap, parent node is smaller than the child. For sorting in ascending order, we use max heap. Let's take a small example of it. First of all, how it works, how heap sort works. So heap sort, basically you have to build a max heap first, means convert the array into the max heap. Okay, how we can convert it means we have to make our parent node that should be greater than the child. That you can say max heap. This is how you can do what max heap you have to build. This means your parent node will be greater than among the child, you can say. Okay, and then we have to extract maximum element actually. Okay, means we have to swap the first element with the last element and reduce the heap size as well and heapify again. Heapify again means what? We have to again build a max heap. Okay, and repeat until the array is sorted. All right, now let's check the small example of it. So here I have written example. This example says what? Array having these elements. The elements are 4, 10, 3, 5 and 1. Okay, now first step, just represent it with the help of tree. So first is 4 here, so 4 will be right now is root. Now 10 is here, so 10 will go as a child. Okay, 3 again will go as a right child. So this 4 is having a left child as 10 and right child as 3. Okay, now you have 5 and 1, so 10, this 10 will get first left element 5 and right element as 1. All right, so this how you can make a tree of this array actually. Okay, I hope you got how to represent it with the help of tree form. So 4 is a node, first element is 4, so I'm making node a parent node. This is the parent node of 10 for 10 and 3. 10 and 3 are the child as they appear like this in an array, and then 5 and 1 is a child of 10 as it's appear like this way. If there is another element, so it will go for 3. Okay, now let's check for the step 2. So how we can do heap sorting in array? We first make the tree form and then we have to what? We have to build a max heap. What is max heap? I told you already that your parent node, these two are parents actually. Okay, but this 4 is a parent for this 10 and 3. Okay, and this 10 is a parent for 5 and 1. As we can see here, the 10 is greater among the child. Yes, that's true. But here 4 is not greater than 10. Okay, so child should be smaller, having small value as compared to the parent. So we have to do what? We have to heapifying it. Means what is heapifying? Means we have to make a max heap. As we are doing ascending, then we have to do max heap. If you are doing descending form, then you have to do min heap. Min heap. Okay. So now let's start the second one. So start with the heapifying from the index n by 2 minus 1. Okay, we have to obviously find out the find out the middle element. Okay, but here we are doing minus 1 as well, so it will decrease the size of your array and you have to go like that way. Okay, so if you are having number of elements 5, then it will say 5 by 2, that is 2.5. 0.5 we have to discard, so 2 minus 1 become 1. Okay, so we start index from 1. Okay, so we have to start index from 1. What is the index? 1, that is 10. Where is 10? This is a 10 actually. So we have to find, we have to make here what? Min heap. Oh, sorry, max heap we have to max heap we have to make. Okay, so this is, I think, we don't need to change anything. 10 is greater among the child, so you can simply write value is 10 right now in one index, that is the parent node. Okay, and child are what? 5 and 1, so they are smaller, so 10 is already larger, so no change should be there. So your tree will look like this right now. Okay, now again we have to decrease our n we are decreasing n minus 1, so n was 1. Okay, so n minus we have to do n minus 1. Okay, so what is it? 1 minus 1 become what? 0. So we are starting index from again 0. All right, now here 0, here is the index 0, here is the index 0, right? 4, so 4 it's here. Okay, now we have to check the child is 10 and 3. All right, if the child 10 and 3, that means what? We have to swap the element 4 and 10. Why? Because 10 is largest. If 10 is larger among 4, that's parent node, you are saying here parent. Okay, so now swap these values, so 10 now will be here and 4 will take place of 10. Okay, now rest will be same. So now heapify the index 1 again. Why we have to heapify again? Means now 4 is a parent but 5 is a child. 5 is greater than 4, then we have to swap it again. Okay, now heapify the index 1 again. Okay, we have to keep checking that their parent node should not be smaller than with the child nodes, you can say. All right. Now the value is 4. Now you have to swap with the 5. So 5 will be now here and 4 will go in its location. All right. Now max, you have already done max heap. Okay, you have now built a max heap. All right, so this is 10, 5, 3, and 4, and 1. So now it's satisfying the condition for max heap. You can check simply here what that all parent node are what are the greater among the childs, right? So how you can say 10 is a parent, 5 and 3 are smaller elements as compared to 10? Yes. Okay, now 5 is a parent for these two elements. They are less than the parent node. That means you have created the max heap. Okay, so this is a step 2, sorry. These are the step 2. Okay, step 1, we have to make a tree representation. Once we have done, then we have to build the max heap. You have to check all the parent nodes, right? All the parent nodes having the greater value as compared to the child node. Okay, now next, third step is what we have to extract the maximum value. So now, okay, so one more thing. Now, previously you have checked the largest element you find out as the parent node. Okay, that is a node, root node, you can say. Okay, so this 10 you will say is a greater. So now you can fix the size to this 10 now. Means you will say it will go in at the end, n minus 1 index. That means you can say here. Okay, all right. Achha, tell me right now array looks like, now array elements are what? Here array elements are 10. First index में 10 you have. Now next 5. Okay. Now next 3 and then 4 and then 1. Okay. So this is how your array right now looking. Okay. These are elements, but it's not yet sort. So we have to make it. So third step says what? We have to extract the maximum value actually. So now you can swap root with the last element. So how we can do so? So this was my array, this was my tree representation. So what is the last element? This is 1 actually. This is what? 1 here. So now swap this 10 with this 1. So 1 will go in the first location and 10 will go here. How it looks like? This is how it looks. Okay, now I have represent 10 in green color. Okay, why? Now it's fixed the position as it's the highest element among all elements, right? All elements of the array. Then you can fix the size for this 10. So now 10 is in the correct position right now. That's in the last. Okay, so you will say you have, obviously you have a swap 10 to 1. Okay, so 1 was there. So 10 is now in this location and 1 is in the now you can say root node. Okay, then 10 goes to the sorted position. It's obviously here. This your array looks like this now. Okay, earlier it was looking like this. So now you have swapped this 10 to the last element. Okay, now once you have done this, all right, so once you have done this, then you have to now ignore this 10 as it's getting its correct position. All right, so 5 you sorry, so you will say 10 you have to remove. 10 you have to what? Ignore right now. That's why I'm showing it in a different color. Okay, now again you have to figure out that it's not now max heap. This is not a max heap right now. Okay, so now heapify again. We have to heapify again. Why? 5 4, you have to ignore this 10. That's okay. It's, you have already done that thing. You can ignore it. Now 5 is in the right position. All right. But what about 1? 1 is not in a right position. As 5 and 3, 5 is greater actually. Okay. As compared to 1. So now swap it. So when you are comparing 1 with 5 and 3, then you have to swap actually with 5. So now when you are swapping with 5, so 5 will go in the 1 place and 1 will go in the fifth place, right? 5 place. So now it looks like this. So this is your array. Sorry, this is your tree presentation for now. So now heapify again index 1. Why? Because now 1 is smaller than 4. That's 4 is a child. So 4 again will swap in this location. So now your tree representation for this array will look like this. Okay. So now 5 is here, 4 is here, 3 is here, and 1 is here. So now you have built again a max heap. Now again extract again. What extract means? You are getting the highest element, okay, in the root node. So now swap it with the second last element. Okay, here as you know 10 you have already built, Hana. You are, that's in a right position. So now you will say 10 is here. Okay, 10 is already done. Now this left. So now you will say 5 will swap in this location. So your array will looks like this. Okay, now I made this 5 and 10 as green. Why? Because now it's fixing the position. Okay, now you have to again check for these 3 elements. It's not in a right position, means 4 need to go in the root position. Why? Because 4 is greater. Okay, so heapify again. So compare it, swap it. So when you are swapping it, I am now not writing these two things here. So simply say this thing, we have to do it. Okay, so 4 will go in the first, you can say root location. Okay, this is a root location. All right, so once you are doing it, it will say now again you have fixed the heap. Again swap, again the swap with the largest element. So the largest element is right now is 4. Okay, now 4 will say go to the 3 position. Why? Because we have to swap it again. Once we are swapping it, your array looks like this. So now these 4 and 5 10 is in a fixed position, so we don't need to bother about it. Now 3 and 1, so it's in a right position, right? So there will be no change. So you have already heapified it. Okay, so now no change, but we have to swap it. Why? जो हमारी क्या largest element होती है, we have to swap with the next element, है ना? Means the last element. So what is the last element? This is the right now last element which you need to sort. Okay, so now swap it. So your array will looks like 1 3 4 5 10. So now it's final swap you have done. That means you got what? Heap sort. You have done the heap sort in an array element. So your array is now become sorted. All right, now let's check a small example of it So here I have an array ARR having elements like this. We have number of elements 5, okay, and I have taken one I as a variable, okay. Now first step is building a max heap. So how we can build a max heap? As I told you, our I will go from n by 2, okay, minus 1, all right, and then I is greater than equal to 0, and I will minus minus, all right. So this is what this we are dividing actually, okay. So it become actually why we are saying it, why we are doing n by 2, because n by 2 by minus 1 will get me the child elements, all right, and the parent of it. From minus 1 we are doing the parent of it, okay. Now inside it I am writing a parent. Suppose parent will get the value of I, all right, and I am writing one more loop to check the element, okay, one by one. Left element, right element we have to check, no? So we have to initialize first and give the value of it. So how it will find out the value? 2 multiplied by parent and plus 1, all right. Again we have left, so now we have right here. So here 2 multiply, again the same thing, but here plus 2 will be there. Why? Because now it will go in the plus 2 position, है ना? So now we have to say one largest element, okay, largest element, and it will get the value of parent, all right. So this is a simple one, okay. Now you have to check the condition. So I'm writing condition here only, okay, inside it. So check condition, we can write if, we can write left, say we have to check, it will go till n, okay, and if it is, obviously, ARR left will get the value, will say is greater than what? Is greater than largest element, right? So I'm writing largest here. All right, so if it is true, okay, if these two conditions become true, then largest will get the largest index we will get from left. But if it is not true, if it is not true, then for right we can set a condition. So I'm writing same thing, okay, but which one is right, it will check, okay, and will update the value to the largest, okay. Right is smaller than n, and left here we have to write right, okay, and is greater than ARR largest, all right. But if your parent is largest, then we don't need to do, we have to break out, all right. So if largest is equal to parent, that's why I have written here parent will get the value of I, okay, one by one it will go, okay. Are you getting a point? Okay, then if it is not okay, then break. If the condition become true, then break, okay. Once we are doing break, then now we have to what? We have to swap it, okay. We have to swap again, and then int temp I'm taking ARR will get the value of parent, okay, and then ARR will get the ARR parent will get the value of ARR largest, okay, and then ARR largest will get the value of temp, all right. So this is how we can do it. And one more thing, largest also, parent will also get the value of the index value we have to make, na? Index value कोई मुझे दिखाना पड़ेगा. Largest will get the value, largest index, whatever it is, parent, it will get the index, the same index, na? And now this is how we can do what? This is how we can, you can simply do what? Max heap you can create, okay. Now once you have created the max heap, that now next step is what? We have to extract the largest element, na? Extract the element. So our element, again we will write for loop. Outside it we have to write for loop, okay. So again, for loop we can write, you can use I also for this, it will go n minus 1 time, n minus 1, okay, we'll get the value, and I will be go till 0, and I need to decrease it, okay. Now again swap, we have to swap here also, swap the first index value. Obviously, your largest element will be, after simplifying, your largest element will be at the 0 index, na? The root node. So AR at 0, that's why I'm writing, okay. Now temp will get the value of this, that's why I'm writing here, it is starting from n minus 1. Why? Largest element is in the root node, and the last element you have to swap with. So that's why, okay, AR at 0 and ARR I. Okay, so ARR I get the value of 10. All right, so this is how we can do it. Now again, do parent as 0, update the value of parent at now 0. Again, you can simply write, it's the same thing, no? Obviously we have to write the same thing. This while loop again, do it, because we have to again check. Again heapify, no? We were doing heapifying again, right? That's why I'm writing it. I'm just copying it here and then pasting here. I will change whatever I require it to change, okay? So now parent is getting 0 value, while condition, okay, again the same thing. Yes, that's true. This is also right. Now here, we don't need to write n, we have to write I. It will go till I now, okay? It will go till I, and again left side, ARR left will get the value of ARR largest. That's okay, and we'll get the value of this. Right will go till I again, okay, and ARR right is greater than your ARR largest. It will again check, and then update the value of largest. That's here, here we have to change, this is wrong. This is right, we have to write, okay? And again, this is also here, right. Right, now done, largest is okay, you will break it. And again, you can take a temp2 variable also. Temp2 variable you can take here. So you will not get any confusion, and your program will be sorted, okay? Now once you have done this, okay, once you have done this, then what we need to do? We need to simply, what? Simply write array, updated array, okay? So int I will go from 0 and I smaller than n, I will increase by 1, and printf. Percentage d you can write, okay, ARR, I will get the value of ARR, I will print all the elements, okay? Written 0, done. So now let's run this code. When you run this code, you will see the errors, okay? Okay, all right, so first let's check out. first, we are creating for loop. This for loop is for what? That element from n by 2 to n minus 1 are the leaves node. Okay, are the leaf nodes. So leaf nodes already satisfy heap property. Non-leaf means childs I'm talking about. Okay, so we only fix non-leaf nodes. Non-leaf nodes matlab, that means parent node. Okay, that's why I'm assigning parent node as I. Okay, now this line is very important. Okay, and when we are doing inside while loop, okay, we are having this loop basically keep fixing the heap until no swap is needed actually. Okay, this loop basically keeps fixing the heap until no swap is needed. Inside we are writing these two things, left and right. Okay, so important concept is this what? That we have a formula action. This is the formula actually to find out the left child and the right child. Without this formula, heap does not work. Okay, so now you can okay, so you can also simply write the largest element will get the index value of parent. Okay, that's okay. Now this part is critical to understand. What is it? This find basically the largest among parent, left child and right child. तो इसमें से हम what we were doing max heap को जब हम find out कर रहे हैं तो what we were doing जो हमारा largest element है ना वो हमको कहाँ रखना है top most में means हमारा root node होना चाहिए. So now this basically this is the core actually core logic of the heapifying. Okay, means we are simply finding who is greater. If left is greater, then largest will get the left element, left index value, and if right, then large will get the right index value. Okay, so if it is okay, then we have to break. The largest हमारा क्या है ना? If the parent is already a largest element, then we have to stop. So we are breaking here. Okay, all right. So otherwise we have to swap the elements. All right, and then if among these anyone is what that true means left is largest, right is largest, then we have to swap. Okay, then we have to swap. Okay, all right. Now this is the extract element. We are extracting the element means हमको the topmost element is the largest element, so we have to fix the position of it. So we will go n minus 1. Okay, so that's why we are swapping here again. All right. So now again we are making a condition. Again we are checking because obviously the last part is already sorted. So we reduce the heap size now. Okay, so we are reducing heap size as well. Okay. Now again, without this thing, okay, so heap structure does not exist. You know very well, I have already told you earlier. Okay, now this is okay, all right. We are again doing the same thing. We are finding the largest element among these, okay, and again we are swapping it. We have to do it until unless the condition becomes false, all right. And this is okay. So this is I think extra. So now run this code. So now this you will see, this is the array. Array is now sorted with the help of heap sort. All right. This is a simple example of it. You can simply write this code as well. And if the examiner will ask, then you can simply write the same thing that we have to find the largest element is in the child or maybe in a root node. So if root node we have, then we don't need to do any swapping. We just fixing the element of it. We have heapify it, and then we have to swap with the last element, the largest element with the last element. Okay. Now let's check the small. Let's check the algorithm of it. How we can write the algorithm. Okay. So now this is the algorithm of it. We have to set largest, okay, as I. We have to set the formula of to find out the left and right child, okay, and then we have to check who is greater. Left child is greater, and if it is, then we have to say the largest will get the left value, and right child if it's greater, then right left. Largest element will get the right. Okay. Otherwise, if both are not equal, then that means the root node is the largest element. We have to check if the largest is not equal to I, then we have to swap the element. Okay, so add the element with the a of I, and it will go a largest. Okay, call again this thing. Okay, once we are swapping it, then again we are calling the same process now. Okay, that time you can write it, and I have written a C program also, no? But you can also use with the help of function. Okay, so that time you don't need to write it again, so just call it there. All right, so this is a simple this is a simple algorithm of it. You can write it. Okay, so the important concept is what heap sort does not divide like merge sort. So instead, it organizes elements into a heap. Always remove the largest element, place it at a correct position. All right. So I think you now understand this concept. So in today's we learned what is heap, how max heap works, step-by-step example. So if you understood the concept clearly, so please like the video, share it with your friends, and if you are new here, do not forget to subscribe for more simple and clear explanation. Okay. Thank you for watching. See you in my next video. Happy learning.